This afternoon, we are going to focus on the markets and uses for both consumers and businesses. Number two, we are going to talk a little bit about the what I would call as the underlying infrastructure looking forward into the future. How do things look? And third thing we are going to talk about is the money. Where are the VCs investing? So to kick off this entire set of afternoon sessions, we have invited Rob Chandhok to provide a keynote address addressing a broad range of market uses and use cases, but focusing on proximity. So it's going to be a very interesting keynote. For those of you who don't know Rob, and Rob in general needs no introduction, he's one of the luminaries in this field. I'm going to read out. It's such a long bio, Rob. It's pretty impressive. I had to cut it down, and still so impressive. So I'm going to read through it a little bit. So Rob is the president of Qualcomm Interactive Platforms and senior vice president of Qualcomm Technologies. He's responsible for Qualcomm strategies that address how people can take advantage of and benefit from the Internet of Everything, wearable computing, augmented reality. And this is all part of the Qualcomm push to drive to the next level of user experience. Specific product offerings from Rob's group, including driving the horizontal ecosystem for Internet of Everything via AllJoyn. I think we'll hear about that from him. Wearable computing via ToQ, and the vision-based computing that underlies Vueforia's augmented reality experiences. So quite a broad range there. Rob also leads Qualcomm Internet Services, which is responsible for large-scale services, commercial deployments, and VoIP solutions for mobile network operators. Earlier in his career, Rob served as the Chief Product Officer for SunRocket, those of you who remember, a pioneer in voice over IP. Worked as a research computer scientist for more than 10 years at Carnegie Mellon. He holds 22 patents, Bachelor of Science from Carnegie Mellon. So with that, Rob, please come up for your title, Keynote.
And I'm going to talk about, as was mentioned, I'm going to talk about the Internet of Things, the Internet of Everything, from, I think, a point of view of a slice of it that I think we haven't spent a lot of time thinking about in sort of the broader connectivity frameworks, because we've been focused on things like virtualization and cloud and getting things basically connected. If you follow me on Twitter, you might actually know that I just actually tweeted and said that I think the Internet of Things is actually a little bit of a misnomer. There's no one category that is all the Internet of Things or the Internet of Everything, although it's on my slides. I think it's actually the next phase of development of the Internet. So we're actually just talking about where we're going to come to in the next 5 years. I think in the next 5 years, we won't even be using the phrase Internet of Things. We'll just be back to calling it the Internet, just like we don't talk about the mobile Internet as different than the Internet anymore. So let's talk a little bit about scale. We all like to put up our numbers there. Different analysts have talked about different projections, billions and billions of devices, tens of billions of devices by year 2020. Interesting for Qualcomm, we think about hundreds of millions of devices towards billions of devices, but we think mostly about mobile phones as the device of that scale. And one of the things that we're seeing now is we know that as that wave of connectivity goes out to the next set of devices, both in home, automotive, enterprise, industrial, the things that are connected, that next wave of things, aren't going to be the bigger things with screens and CPUs and big connectivity. They're going to be a wide variety of devices ranging from very constrained to very capable, but all needing to be connected, all wanting to be connected, it being useful for them to be connected. So you'll start to see things like, I think in the next year, we're already announcing with partners some stuff based on our technology that has to do with media, in particular speakers. That's why that's up there, and I'll talk a little bit about that. But I think lighting is about to turn the corner. So as LED lights have come into fruition, you can start to see attempts at vertical environments for controlling the lighting in new ways. The CEO of LifeX, which is one of the companies, remarks sometimes when he speaks, he says, once you've had a light bulb that does more than just turn on and off, you actually never want to go back, because it's kind of like going from black and white television to color television. You can make little adjustments, not I want my room blue, but I might want it a slightly different shade or color to make me feel warmer or cooler, both shades of white, right? So there's a lot of things that are happening and that we have the capability and the richness to actually control. The question is how we're going to do that and how we're going to build these systems and how we're going to have an ecosystem on which both companies like Qualcomm and companies like the entrepreneurs in this audience can start in order to build an ecosystem just like the ecosystem that drove the web the way it's been for the last 15 years. Characteristically, I think we could put some of these devices, if again, stepping away from the sort of industrial side of the Internet of Things, we can put them into categories where we think there is still going to be sensing, so things that are going to help you be aware of what's happening around you in places that you own physically, like your home or your car or your office. You're going to be able to interact with those things in new ways that you didn't have. And one of the projects that we worked on, and one of my teams launched this Talk Watch, which is our watch, which actually uses the same protocol that we are going to talk about later called AllJoyn, so you could actually control things from your wrist in sort of a way that neither team thought was going to happen when they both started the project. So that synergy exposed new experiences and new behaviors. And the last bit, which I'm going to spend a little bit of time about also, is thinking about what connectivity means. A lot of time when we talk about connectivity, especially on the device side, we tend to categorize things by their physical nature of the connectivity. Think about it. You have a Bluetooth headset, right? Or have this Wi-Fi light bulb, right? Whereas on the internet side of the world, we abstract that all away. We don't say that server is an Ethernet server, right? We just say it's on the internet, it's in the cloud. So I think part of the evolution of where we're going to go is we're going to break down the barriers and really put the right layers between the software protocols that the developers are going to use to build experiences and the physical protocols that we're going to use to connect these things, because they change at different rates and you innovate on them at different rates. So right now we might be using Bluetooth and Zigbee and Z-Wave and Insteon. In 5 years we might be using 60 gigahertz and 802.11ah, which is the low power version of Wi-Fi. But we don't need to change the software layers, or we shouldn't need to. And as it stands right now, we would have to do that because things tend to be written to their software layers. So I like to put this picture up a little bit to talk about where we are, because sometimes when I give this talk, people think, well, you might actually be, you're making a point about something that isn't a problem, because we already have Internet of Things stuff. And I think back, actually, one of the great quotes that I really like to explain this is actually from the head of Qualcomm Atheros, Amir Feintuk, who walked around the floor at CES, and one of the things he observed is, a lot of people are talking about Internet of Things, but they're really, what I see out there is the Internet of Thing, singular. And the Internet of Thing is, I go and I build my device, and I put a connectivity on it, either Wi-Fi or Bluetooth or to bridge to a phone, and then I connect it back to my cloud server, which connects it back to my application in the App Store, right? But there's no things involved. There's no interoperability. If I want to go from interacting with that thing to interacting with another thing, I have to quit an app and go to another app, and there's no synergy there. So what we're trying to think about is how do we break that paradigm and actually have Internet of Things, right? Now, you can argue that I could connect all these things back on the cloud side, and that's a reasonable thing to do for some of the parts of the experience. So if you look at systems like If This Then That, and some of the other capabilities that are companies that are coming out, they do that more in the back end, and there's a great role for that, and that's actually very important. I'm not trying to make the point that that isn't important. There are, however, experiences that have to be driven locally, right? Either for latency reasons, I have to do it fast, and sometimes going out and back to the cloud isn't fast enough, or I might want to keep it private. Maybe I don't want somebody to know when I'm turning on and off my lights or turning on and off my locks, or that I'm viewing a video of a certain kind. Maybe I want that to be private. And then the lastly, I might want to also think about things being secure, right? And I'll talk about that in a little bit. So keep those things in mind. So I don't want you to walk away thinking I'm saying local communication good, cloud bad. I want you to think about the fact that as we move forward, the architectures that are going to be successful and that are going to build the experiences consumers want are going to be more complex than simple client server, right? It isn't just going to be an app talking to the cloud server that's going to do what your mom thinks it should do when she walks into the room. It's just not going to happen, right? Or at least I don't think it's going to happen. So what kinds of things, what kind of capabilities are we talking about when I talk about the proximal Internet of Things or the Internet of Things near me? I want to be able to do things like discover devices, right? It's very important. How am I going to build an ecosystem if I can't walk into a room I've never been in before and interact with it? I should have been able to perhaps come into this room with my slides on my laptop or on my smartphone and find the projection system and perhaps have the permissions to project the slides because I'm in the room. Because I know if I goof while somebody else is presenting, it's going to be pretty obvious it's somebody in the room. Maybe that makes more sense in a smaller meeting room than this. So I'm going to discover things. I want to identify not what the devices are, but in particular, I'm very interested in what services are available on the device, what APIs are available. So you want to be able to ask, what do you do? And it's a really interesting approach that I think we took here with the system that we built, is that we decided not to try to enumerate every device in advance. We decided to make it capabilities oriented. So what you do in our system is you don't look for a thing of a device of a certain kind. You actually say, what interfaces can you offer me? What services can you provide me? And think about this. The easiest example for that one is a multifunction printer. Is it a multifunction printer? Is it a printer? Is it a scanner? Is it a copier? Well, in our world, it just happens to be a thing that physically embodies 3 or 4 interfaces all wrapped up into one device. So I can print to it, but I maybe can print to that TV if that TV exports that same interface, and that's how I could show you a picture from my smartphone, is I could pretend I'm printing it. So thinking about how you identify what you're going to interact with is important, because as these device ecosystems grow, you're going to get emergent behavior. Things are going to interact in ways that the original designers of the devices did not predict. So you want to build a system that actually can be very dynamic so that new things can happen, right? We want to hide the connectivity, so managing and adapting. We want to hide Bluetooth and Wi-Fi and Zigbee and Zigbee, all those things from the software developers. I don't want it to be the case anymore that if you're going to do something cool in the Internet of Things, you have to be a Bluetooth expert. Because if you're going to do something cool on the Internet or on a mobile phone, you don't have to understand how LTE works. You don't have to understand how Ethernet works. You understand how HTTP and the services and web APIs that we build on top of that work. So we want to do that same thing. And by hiding that complexity in this proximal world, I have to do some things that some networking protocols don't do as well. So I have to think about, if I'm going to build a mesh of all the devices in this room, and one of us walks out, I have to be able to make sure the mesh is robust in the face of those kinds of changes. And we've spent a lot of time doing that. I want to interoperate across different operating systems, and that's really important. This isn't specific to any particular device or runtime. We've implemented this protocol on things ranging from very small 30K code space devices that are edge nodes, they don't do full routing, all the way up into Windows 8 and big Linux servers, because you don't want to have different protocols to actually do that interoperability, and you don't want to make it specific. My personal belief is if I had a car, I wouldn't want one of the accessories to the car to be specific to a particular phone's operating system, because I don't know, in 10 years, I'll still have my car in 10 years. Maybe everybody else here gets their cars updated faster than I do. I don't know what the phone operating system I'm going to be using in 10 years is going to be. So I want an open, interoperable ecosystem so that people can add value at different points in time. I want to be able to exchange information and services, so that involves some standardization. And I want to, from the beginning, design it so that it can be secured. Right? I don't want security to be an afterthought. And that really means I want to design for security that can be updated over time. So as we get better at security, that part of the system has to be able to grow as well, right? So if you think about that, and this is why we get to this sort of construction of the Internet of Things near me, a lot of the things that I've talked about, things like security and how we discover service and so forth, in the broader web, we've actually have systems that do that. There are whole conferences on web APIs and ecosystems, right? We saw what just happened with the Heartbleed bug and how the community responded to that. That's some parts of the security framework of the Internet, but there's far more going on there. we're not trying to change those. We're trying to say, we want to bring a whole new set of devices, and this is one of that part of that family that we're going to think about. So I also like this slide. I want to just make one point about it. I made a little bit of point about security, and I just want to sort of use this slide to talk about what security people call surface area, right? One of the ways you, by design, think about making your systems less susceptible to attack, because we all know that the systems will be attacked. There's no silver bullet here, is you reduce the places at which an attacker can get into. So one of the design concepts that we thought about very hard was make the communication as local as possible, only go out if you have to go out, right? So it's the opposite of go get a device. I say I want to do Internet of Things. I put it on the internet with an IPv6 address, and I put it on the public internet, and I manage it in the cloud. Well, what if I end up with 300 devices, 150 of which are less than $20 and manufactured somewhere where they don't actually understand security? They become a vector into a very private part of my life, right? And so I don't want that to be even in the design if I can. So I want that $20 toaster to actually only talk to things that are in my house and not try to reach out into the public internet, because I don't believe that they'll be secure enough in doing that. If I want something to securely go out, if the toaster needs a service, I want it to go through a gateway that has enough CPU, horsepower, and hardware to be secure in the face of the barrage of attacks that will come from the public internet, right? So that's a design principle. That doesn't mean that it's perfect or anything like that, but that we were trying to start from these principles so that we designed for privacy, security, scalability from the beginning. And that's just things that we learned along the way. And I'd say along the way of watching the internet for the last 20 years. Right? I think I've talked about a lot of these points. Maybe I'll talk a little bit about flexibility and ecosystem a little bit. So we designed, and in a move that I think a lot of people think is interesting for Qualcomm, open sourced a platform, a software platform that embodies these design principles. We first started actually about 4 years ago, and we tried to just use things that were out there. We just tried to use UPnP or Rendezvous and build systems on top of that, and they just simply didn't work well enough, and there weren't enough interoperable implementations. So we actually based our system on another open source project called dbus, which is, for the software people in the room, came from the KDE project, which is where WebKit came from. And dbus was a way for a message bus between two applications on the same processor. And we just said, well, what happens if we can send messages between these things, but they can be across a wireless link? What could you do then? But you have the same message bus architecture, which is very rich for software developers, and you just say, we'll make it work over Bluetooth and Wi-Fi and Powerline and Ethernet. So that openness has come in very handy for us, because it's allowed us to go to partner companies and say, here's something that we don't control that we can do together, and then we can grow an ecosystem on top of this horizontal substrate that all of us can then build businesses on top of. Because it isn't useful for us to differentiate on the way that we send this data around at that level. Just like the difference between what I would think of as the internet and the web, right? When the internet first started, I remember the point where we transitioned from, I tell these stories and I keep forgetting, it reminds people how old I am, where we transitioned from dial-in modems, and then we went to broadband connections. But people were still starting up the AOL application and going to AOL, or they're starting up Prodigy, and they're starting up CompuServe. The only difference was they weren't dialing into dedicated modem banks, they were using this broadband connection. And then Mosaic came out, and Netscape, and the web, and the things that Tim Berners-Lee did, and all of a sudden, things got really different, and the interoperability started to matter, because I could put together new experiences and servers by mashing up together ads from over here, and maps from over here, and graphics from over here, and tools from over there, and then present user experiences. And it drove an economy that we all are benefiting from now, and in fact, we're still building upon these days. We want to create that kind of economy in the Internet of Things on top of an open, horizontally scaled platform. So that's really one of the fundamental things there. So we're trying to make sure that as we build it, that the building blocks we build are small enough so that developers like those in the room here can build experiences on top of it. So let me give you a concrete example of that. If we had an interoperable protocol for controlling LED lights, then I don't have to worry about if I buy this brand of LED lights that I have to buy them for the next 15 years because otherwise I can't control them all from the same application in my house. What I can say is I can buy multi-brand LED bulbs that all speak this common protocol, and then I can go into the marketplace, into the Play Store, or into the iPhone App Store, and I can say, which developer has built a great experience for controlling the lights the way I think about it? And I can pick one of the 20 applications that embody the experience that I want, and people can innovate on that value. And some people will take that as a standalone app, and some people will integrate it into security systems and other things, but there won't be a barrier to entry. You'll be able to create experiences on top of that. So it's not that we're driving value out by saying it should be horizontal. We're saying don't differentiate on the things that aren't interesting, differentiating on the things that really consumers place value and businesses place value on. All right, so that's really the ecosystem that we're trying to do. So I want to draw the analogy again just to make the point of it, that the web ecosystem really has driven the economy because of the interplay between what websites do and how they get services from there. So you can look at any website that you go to now these days, almost none of them have any independence, right? And some of this was actually seen when you see some parts of the internet have routing problems. All of a sudden, everybody's web page stops working. Because if you look at it, and we for a while worked on the mobile web, optimizing the mobile web a lot on the team that I used to run at Qualcomm, and you realize it's something like on the order of 50 to 60 different HTTP requests you do just to show the average page on the internet of a, sort of a well-defined service, because you get a little bit of graphics from over here, you get a little ads here, you get some analytics from this company that you're buying it from, right? And that all grew out of an economy based on a protocol, HTTP, and then a layer on top of that of web APIs, so either REST or JSON, or there became some standards for doing that. So if I want to build a web page and I want English language completion of words as my user types, I can go buy that service from somebody. I don't have to build a dictionary myself and figure out how to write the JavaScript. I can just go buy that service, right? So building this interoperability, the point I'm trying to make here, building this interoperability didn't destroy value or make everybody the same. In fact, it created opportunity for everybody on the web. So hopefully everybody can agree with that. And if you see that, cross that over to the device. And I'm using homes here, and I want to stress also, AllJoyn is not a home automation protocol. It is you can embody home automation on top of it, and that's one of the working groups in the Alliance that I'm going to talk about. But the examples that I use tend to be home-oriented because that tends to resonate with most people's experience. So when I talk about interfaces, think about it this way. I'm standing up here on stage, and maybe I would like my house to pretend that I'm home tonight, right? That's actually a pretty high-level API. I could have a controller in my home or a service that I get from my cable operator or one of my service providers that I trust. They could present that interface out to the public internet so that I could get to it from wherever I am. But I don't need to know every light bulb's address while I'm standing up here on stage or while I'm sitting in my hotel room, right? Because that's not the right level of API. So if we allow APIs to interact with each other, I can build that controller that sits at the edge, and then I can expose those APIs out to other parts of the ecosystem, even perhaps if this then that, if that's what I wanted to use as the interface, right? So we're trying to figure out, and this is actually an interesting design problem. We're having lots of really healthy debates, I think, in the group of companies that are working with AllJoyn about what are the right APIs. Because if you're in this room and you've ever done API design or standards design, you know that figuring out the right building blocks is critical to the success of the system going forward. So we're spending a lot of time thinking about that. But that's one of the powers of doing this as an open source project, is that we can get a lot of companies who have experiences in different parts of the system and get them to come together and make the system better for everybody, right? And that's one of the design goals that we have there. So think of some of what we're trying to do with AllJoyn as bring that same API ecosystem that we have on the web that was so powerful, both from an experience and from a commercial standpoint, and make it work for devices that are around us. And in the home, in the car, in the room I'm in. So I think I've covered the points that I wanted to cover. I don't know, am I making up time? We're good? So let me just maybe close with a couple more things. So one of the things that we've learned and what we've been thinking about is that there is so much opportunity here just by actually working together. So let me, if I can, go over a little bit about what the Alliance is. As of right now, we have The alliance for AllJoyn is called the All-Seen Alliance, and it's a long story about why it's not called the AllJoyn Alliance, but it's called the All-Seen Alliance. And as of right now, there are 50 companies in the alliance. And those 50 companies are together because they believe that this part of the system isn't something that needs to be differentiated. They believe that the value for their own company can be enhanced by participating in making these things better. Some of us in the alliance talk about this as being the HTTP for the Internet of Things. And that's a bold claim, right? And the only reason I even feel mildly comfortable making that claim is because if there are holes in the design, if there are things that are incorrect in it, the community can actually fix it. So if you remember what HTTP and HTML were early on, they're very, very different than what HTML5, what we think of as the HTML5 system is today. So we're at that stage now where we're starting to do some interesting things. For example, we've got TVs from LG that are going to launch with simple services built in them, like this open standard we have for a notification service. Think of it as SMS for your devices. So you can have an arbitrary device send a message, and it will be displayed on the LG TV without LG knowing anything about it, because it's an open standard interface. So I can build a little widget on my Android phone, even if it's not an LG Android phone, that displays the caller ID. So if my phone's over there being charged and I'm watching TV over here, I can see the caller ID, right? Or maybe my washing machine, instead of playing a song when the load is done or the load is unbalanced, and I have to figure out, was that the good song or was that the bad song? You give UIs to things that don't have to have UIs. So instead of putting an OLED display on that washing machine, I can use other display surfaces that are around it to actually communicate something interesting. Or my refrigerator can say, you left the door open, not just beep, right? So a lot of things can, and maybe beep in a place that I don't know. So a lot of those things are really rich for opportunity. This year we're also going to see, and Panasonic has announced, open Wi-Fi-based speakers that are based on audio streaming protocols on top of AllJoyn. And there are a bunch of manufacturers that have committed to bringing those out into the market. And as I've hinted at, we're working with some partners on some really interesting things in lighting. The next things will be things like how we gateway this into the cloud, and how, and really, in all honesty, the next things are going to come from the member companies themselves on what we're going to focus on. So if you're interested, please go to allseen.org. The URLs are actually on there, allseenalliance.org, or alljoyn.org will actually redirect you to it. AllJoyn is with a Y. And thank you for listening, and hope you have a good rest of the afternoon.